Hi everyone. I received this question from my one of the students from my micro class. So let's go over it. I think it's question number. See a question number in here. Question 4 from chapter 8. Okay, so we have a production table. So basically, we have the combination of labor and capital that is associated with different level of output. Notice that capital is assumed to be fixed and labor is variable. So capital is 15 units and labor is the variable input in this case. The question is asking us to calculate the total variable cost. So to calculate the total variable cost, all what we need is the amount of capital and the price of capital, which is 5, and the amount of labor and the price of labor, which is 8. So the calculation is very straightforward. So the price of capital is 5, so 15 multiplied by 5, okay, just right, plus 2 multiplied by 8, that's the price of labor, right? So 15 multiplied by 5 is 75 plus 16. So that 75 plus 16 should be 91. We repeat the same process right here. This is multiply this by 5 plus 6 multiplied by 8. And you do the calculations. So I'm just gonna do it with my calculator here. And just fill in the numbers. So 91. And here 6 multiplied by 8 is 42 plus 75. Sorry, 48 plus 75. So I got this number 1.3. Again, over here is going to be 75 plus 9 multiplied by 8. 9 multiplied by 8. And 9 multiplied by 8 plus 75. So I got 147. $12 multiplied by 8, 96 plus 75. So I got 171. And 16 multiplied by 8 plus 75 is 203. 22 multiplied by 8 plus 75. So I got 251. 30 multiplied by 8 plus 75. That's 315. 40 multiplied by 8 plus 75. That's 395. And 52 multiplied by 8 plus 75. That's 491. And finally, 66 multiplied by 8 plus 75. 600. And Okay, now we move to the second part. All right, so we calculate the total variable cost. Now we need to calculate marginal cost. Just to remind you, marginal cost is change in total variable cost divided by the level of output. It's important to keep an eye on the notation, right? So I usually use capital Q for output in here. It's a small q for output, right? So let's just do it for the first one, right? So the change in total variable cost between 0 and 1 is 91 minus 0 divided by 1 minus 0. So it's 91. Let's do the calculations for between 1 and 2 right here. So change in total variable cost is 123 minus 91 over 2 minus 1. Okay, so the answer should be 123 minus 91, 32. Okay, gonna repeat the same calculations for the entire numbers in here. So between 2 and 3 will be 147 minus 123, divided of course by 1. So I got 24. One 71 minus 147. I got 171 minus 147. I get again 24. So 3 minus 171. I got 32. 251 minus 203. I got 48. 315 minus 251. 64. 395 minus 215. I got 180. No. 395 minus 315. 80, not 115. Okay, 491 minus 395. That's 96. 96. 600. 603 minus 491, and that's 12. Right, 112. 603 minus 491. Okay, and then check your answer. All right, now the second part is to calculate average variable cost. All right, to calculate the average variable cost, what you need is your total variable cost in the amount of output. So you just divide total variable cost by the amount of output. And we will do it right here in a second. All right. Here we go. So just to remind you, average variable cost, simply you look for the total variable cost and you divide it by, well, variable cost. Total variable cost. TVC. And you divide it by output. Q. Right. So 91 divided by 1. So we're going to get 91 in here. 123 divided by 2. So 123 divided by 2. I'm going to do it using calculator, which is faster. Now it's to round it to 2 decimal places. Okay, 147 divided by 3. That's 49. 171 divided by 4. So 171 divided by 4. I got 42.75. And 203 divided by 5. 40. 48. No, not 48. 251 divided by 6. I got 41.83 repeating, but we can write 3. 315 divided by 7. Got 45. Again, I'm just dividing these numbers by the amount of output. For 80 is going to be 395 divided by 8. So 395 divided by 8. So I got 49.375. So that we rounded to 38. And 491. And divide that by 90 or 9. So I got 54.555 repeating. So we rounded to point. Oh no. 54.6. And finally, 603 divided by 10, we should get 60. Oh. Here we go. Okay, now we move to the second part, the graphing part. So we need to graph these two curves. We need to graph the marginal cost curve and the average variable cost curve. Remember, like in the last lecture, we should get something like this. This is like for the marginal and something like this for the average. And so this is the minimum So this is the average variable cost, and this is the marginal cost, and this is the minimum average variable cost, AVC. All right. So to graph this, I think you would need like to know 3 points. Like, graphing in here is just simply a skill. It's not like, science. Basically, it's, skill. So you need the first point and the minimum point, and then the last point, right? And then you connect them. And we're going to do the same thing for the marginal cost. We're just going to find out the first point, the minimum, and the last point in here. So let's do that. So I'm going to erase this first. And graph it using the graphing tool so we can check the answer. Here we go. All right. Okay, so we're going to start with the marginal cost. So the first point is 1. So 1. The marginal cost is 91. So 191. And 191 right here. Now it's like not easy to get it exactly, especially if you can't type the coordinate, but let's try. All right. So I think the platform will give you some degree of freedom. So, okay, have 1.01. It's close enough. I think that's gonna work. If you can't get it exactly at 1, that would be great. But at least Pearson will give you some degree of freedom for certain questions. Now we're gonna look for the minimum marginal cost. And the minimum marginal cost in here is 24. So 24, and we have 3 and 4. I'm gonna pick up 4, right? So 4 and 24. 4 and 20 should be right here. All right. $24. Okay. Maybe it's easier to type the coordinate 24. Okay, I think I would just have it. I think this should be close enough. I couldn't do better than this. And then the last point is 10. When quantity is 10. Quantity is 10, marginal cost is 112. So 10 is right here. We don't have 112. The maximum I have in here is 100, right? So, so 10 I got it before. Okay, so this is the marginal cost curve. Let's label it. We do the same thing for the average cost. So we need 2 points. So 1 and 91, they start at the same point. So 1 and 91. 91. And the minimum average variable cost is for 40.60. 40.60. And that's achieved when the level of output is 5. So 5 right here. We need to look for 40.6. So 5, 4. I don't have 0.6 in here, but 0.7. So I will use this one, which is a good approximation. And again, when the level of output is 10, average variable cost is 60.3. So 10, 10, 60.3 is somewhere right here. Oh no, 60. Point. All right, so this is a good approximation. Actually, can do 10. So this is the average variable cost. Okay, let's check the answer. Well, with that being said, notice that yeah, the platform is not very accurate. Like I would say this is the minimum point, right? And this should cross the average of the minimum point. So I cannot move it, but at least we should get something like that. Okay, we are not done yet. So the cost curve have the curve of the shape you might expect because they decrease initially and then eventually increase due to. So why does the cost curve increases, right? You remember that we have this sort of shape of the total like um, cost curve. It decreases, then it increases like that, and and um, and I said like that's related to the shape of the production function, right? We have this sort of shape production function, and we actually we have duality, right? We derive the cost from the shape of the production function, and the reason we have this section with the cost curve is because of the principle of diminishing marginal product, meaning that beyond a certain level, maybe beyond this level, right, each additional unit of input will give you less and less output than the one before. You cannot just keep applying workers and getting more output if you have the same um, amount of capital stock, right? So diminishing returns. Perfect competition doesn't have to do with the shape of the cost function. Fixed cost, no, it's because of the diminishing returns. Each additional unit of the variable output will give you less and less output than the one before. And let's see if we are done. I think that's it. Thank you.